All right, there's actually a lot of stuff that we can do with rotations. Basically, I just kind of give you kind of the overall kind of concept about what a rotation is, and then we'll break it down and see if we can develop some rules that are useful. Ultimately, what we're going to do is we're going to take a point, and that point can be anywhere in the coordinate plane that we want it to be, and we are going to basically implant a circle centered at what we call our point of rotation. And that circle is going to pass through the point that we are rotating. Okay? Now, we never really draw the circle, but I want you to see what's kind of behind the scenes. How many degrees are there in a circle? 360. Okay? So if I rotate, let's just say 30 degrees, let's say 34 degrees, essentially what we've done is that we have moved this point along the circumference of that circle 34 degrees, meaning that that angle right there between the origin to my pre-image and the origin to my image, that angle is that 34 degrees. Does that kind of make sense? Now, it might make, eventually kind of maybe more sense to recognize what happens if get rid of this circle real quick so I can move this point. If my point started there, and then we move around that circle, okay, and you can see that the logic is, well, if I move 90 degrees, our point P prime should show up there, correct? Does that kind of make sense? Okay. And then if we keep going, 180 degrees is going to be right there. And then how far would that be right there, down here? I know you can't see it. Be about 270. And then getting back to itself would be 360. Okay. So that's kind of what we're going through here with this. Now, the logic is, let's see if we can, let me just hide this point real quick. Rotate. If I can do that with 1 point, I should be able to do it with 2 points and 3 points and 4 points. So I should be able to rotate an entire figure. Does that make sense, everybody? Okay. Well, I'm going to focus on today and for the most part on Monday, it's just dealing with 1 point. And how if we do it at 1 point, we can replicate that process with as many as we need to rotate an entire figure. Okay. However, what I want you to understand is if I look at that triangle there and that triangle there, and I show distances and all that kind of stuff, they are the same. Okay? Those triangles are congruent. Does that make sense, everybody? So this is a rigid motion. This is a situation where distances are preserved. Okay? So let's kind of talk the notation that we're going to use. And notation stuff, as always, is somewhat confusing sometimes because not everybody follows the same type of notation. There's sometimes notation that has understood statements when it's not written. So kind of give you maybe several different things you might see. They'll say capital R. So now we're thinking rotation or reflection. That's the issue. But now they'll put maybe like 90 degrees. If I put 90 degrees there, do we know it's a rotation now? Okay. Now, right now I'm going to try to help you develop some rules that are rotations about the origin. Okay. So sometimes they'll just put R of 90 and then as 90 degrees as a subscript, and then we'll put your ordered pair A comma B, and we'll write then what does that provide us, okay? And again, this stuff here, this is your pre-image ordered pair, and we'll talk over here that this is your image. But some things that are kind of analogous to that, they might write it this way. Okay, that is the letter O. Okay, what do you think O stands for? Origin. Okay. I've seen sometimes they write it this way. Instead of writing the letter O, they might write the word origin. Okay, my cursor froze, so there we go. They might write origin there. Okay. But the lack of it, like we did at the beginning, it's like this one here. It's an understood origin if there's nothing written there. Does that make sense? They might also say, rotate around point A. Right here is point A right now, but I can move it anywhere that I want to. Okay, and I can rotate around that point then. And that's what we'll kind of focus on next week. And they might even, instead of saying point A, they might do this. They might put an ordered pair there. Okay. So there's a lot of different things right there that they can do. They can leave it blank and not put anything there, and that means origin. They can put the letter O, and that means origin. They can put another letter that might represent some other point, okay? Or they can actually put in the ordered pair. And I've seen those all being used. It's just kind of the author's preference, I guess. Okay. Now we're going to focus on 90 degree, 180 degrees, and 270 degrees. And right now we're going to focus on going counterclockwise, okay, with our rotations. Okay? And that will be something that we kind of mess around with and change as we move throughout rotation. Because circular motion, and this is always an issue with circular motion, whether you be in geometry, physics, trig, you have two directions you can go. Okay? If I go, for instance, let's go back to, let me see if I can get back to that circle that I had in here. I guess I'm not going to be able to. If I think about the circle that is going through there, and I want to rotate that thing so that it gets to here. I could rotate that many degrees. That's a terrible circle. But I could rotate that many degrees that direction, right? That's 270 degrees counterclockwise. Can I get that point to get to the same spot that direction? By going how many degrees? 90 degrees clockwise. Okay. So that discrepancy is always an issue when we talk about circular motion. And that's really what we're doing with rotations here. So we've got to pay attention to that. Our rules that we're going to provide, and this is usually the case unless stated otherwise, our rules are written in regards to moving counterclockwise. Okay? So if they ever say rotate clockwise, you have to adjust the rule a little bit. And we'll talk about that on Monday. Is probably when we're going to have a little bit more time to talk about that. Let's see here. Let's go. I'm going to write R. Let's go 90 degrees. Okay. And right now I'm just going to write the word origin in. We're going to use the point A comma B. I want you to see if you can make a relationship like we did yesterday with reflections, make a relationship over what's happening here with these points. And if I want to do, I don't know if I said this, if I want to do an angle that is more than 90 degrees or less than 90 degrees or not a multiple of 90 degrees, we have to use protractors and stuff like that to do that, and it's kind of a pain in the butt. So that's why we're only going to use these 90-degree ones. So I see a show an angle of rotation here. So right now it's 31 degrees, and there's really no link between your x and y's here and your x's and y's here, right? Or if we call them a comma b's, there's no link between them. But when we get to 90-degree rotations, is there a link between my pre-image of 6, 0 and my image of 0, 6? There is a link, right? Now here, I just want you to be careful here, because 0, 6 and 6, 0 is really not a good point to really test the rule here, because when I use 0, there could be a plus or a minus on it. Does that make sense? So we got to be careful with that. But right now with that, you're seeing at least that they flip-flop spots, right? Let's see what happens if I move this point P to be 6, 2. That 90 degrees had to be maintained for my rotation, right? What happened to the ordered pair now? Yeah, so they flip-flop, so it became B comma A, right? But now this first coordinate, your x-coordinate of your image, is negative, or the opposite of what it was over here. Okay? Meaning then, if I ask you, okay, let's do a rotation of 90 degrees about the origin for, let's go 3 comma negative 4. Okay? So I apply this pattern then. So this pattern says they flip-flop. So it becomes negative 4 comma 3. And then I introduce this extra negative here, right? I negate that first one. So when I negate the first one, I get a negative, or the opposite of a negative, which turns into a what? Positive. So if I ask kind of GeoGebra to look at this and verify this for me, if I started at 3, negative 4, right there, do I get the 0.4 comma 3? Yeah. Okay. And you can test that out with, essentially any point that you're interested in. You're going to see that relationship. If I start with A comma B, it becomes negative B comma A. Is that all right? So that's one rule that you're going to want to commit to memory. Now, yesterday I said your memorization is going to fail you at some point, and that's my fear here with these, because I'm going to ask you to memorize those, because I don't know if there's going to be a really nice way to, other than writing equations and using them together as a system equation, to come up with this rule again. Okay, so memorization is really the nice thing here. And when I mean systems of equations, guys, what I'm talking about is you could develop this rule, I would think, by being able to say, that is A, that is B, this is 0, 0. I should be able to come up with an equation for that thing right there, giving me then the equation of that, because they're going to have opposite sign reciprocal slopes, right? And I should be able to write an equation for this line and then know that I need to move out on that line essentially 4.47 units, which I could find using the distance formula, to find the location of that point in regards to its A and B. But that's way outside the scope of this class, and probably outside the scope of mini Algebra 2 classes. Okay? So my suggestion with these, you're going to memorize, which is nice because now we've already talked about reflections. We don't have to memorize those. So at least we can just focus on these essentially 4 or 3 rules. I think 3. We did 90. What's another nice multiple of 90? 108. Multiple means multiply that by an integer. '90 is a multiple of 30. 30 is a factor of 90. Okay, so if we got that, okay, so let's go 180 degrees. Let's see what happens when we rotate here 180. What happened to your ordered pairs? Okay, they stayed in the same spots, right? So it's still A comma B, but now they're both negative, right? And that's, does that maintain here at 4.4, 4.68, comma 3.35? That pattern's being maintained, right? Does that maintain here? Like, let's say I have that point there. Do they stay in the same spot and negate? Yeah. Positive 4 negated is negative 4. Negative 2 negated is positive 2, right? Same thing if I start over here. If my pre-image is over here in the third quadrant, negate both of those, and you get your image over in the first quadrant. Okay? So 180-degree rotation, I think that's usually the one that people recognize the easiest with rotations. Here's a question. Let me take this point, P, and do that. So I reflected across that line and gave you that point there, right? What reflection would I need to do to take this point and get it there? A reflection over that line, right? Does that make sense to everybody? So a 180-degree rotation is equivalent to x-axis reflection followed by a y-axis reflection. Okay, I'm going to write it that way, but you could have also reflected on the x-axis and then reflected on the y. The order doesn't really matter then. And that's something that they often ask you when you write or do a problem. They'll say, okay, do a 180-degree rotation, and they say, okay, how can you rewrite that rotation in regards to reflection? Or vice versa. Here's two reflections. How could you write that reflection in regards to a rotation? Okay. Let's do one more just to wrap things up. 270 degrees would be the next one to deal with. What are you seeing happen with those two ordered pairs?
They flip and the y turns negative.
Right. So there are some patterns here with our rules. Right, A, B, or sorry, O for origin, A, B. So now you're saying they flip-flop, so it becomes B, comma, A, and now the A is the negative one, right? Can you see that there is a relationship, and this might be an association that allows you to kind of remember these. Would you agree that these two, they both do the same thing with flip-flopping? Okay. But in the first one, this first coordinate is negative. And in the second one, this one is, the second coordinate is negative. Now, the way I remember that, which rotation would you come across first, 90 or 270? 90. So that's the first rotation you come across. So that's why the first coordinate in the image is the one that I apply the negative to. Okay? So if you can develop those associations and relationships, it's going to allow you to remember those things a lot easier than just trying to take a picture in your brain and then copy that picture down at some point. Okay? Those should give you a start on the assignment that I'm going to post here in a little bit. It is not due on Monday. I'd be due Tuesday, but you can get a start on it. My hopes are to have all of your